This is Theory of Change. I'm Matthew Sheffield. Thanks for joining me. Space aliens are one of the most common tropes in science fiction, and with good reason. We live in an immense galaxy, and there seem to be a massive number of planets out there. Surely at least a few of them are inhabited, right? Well, most Americans do appear to believe this. A poll from November of 2025 found that 56% of adults surveyed said that they thought aliens existed, and former President Barack Obama appears to be one of them, based on a recent interview that he did with podcaster Brian Tyler Cohen. But whether aliens exist or not is one of so many interesting questions that the scenario presents to us. And there's one that perhaps you might not have thought of, which is, if we ever met them, how could we even communicate with them at all? In novels, films, and television shows, decoding languages from aliens seems to always be a quick affair. Math is math, and symbols are symbols after all. But that assumption is a very big one if you think about it a little bit more. While they may seem to be universal, science, math, language, and numbers, even, are human constructs, even though they describe relationalities that seem to be real. My guest on this episode is someone who has thought a lot about all of this. His name is Daniel Whiteson, and he is a particle physicist at the University of California, Irvine, and he's the host of a science podcast, Daniel and Kelly's Extraordinary Universe. And today, though, we're going to be talking about a book that he's out with, which he co wrote, called Do Aliens Speak Physics? And Other Questions About Science and the Nature of Reality. I hope you'll enjoy. Theory of Change is part of the Flex Media Network, so go to flex.community for more podcasts and articles about politics, science, religion, and media, and how they all intersect and create our culture. And if you like what we're doing, we have paid and free subscriptions on both Patreon and Substack. Just go to patreon.com/discoverflex, and you can go to flex.community on the Substack side. And if you are able to do a paid subscription, you have unlimited access to the archives. And I thank you very much for your support. And if you can't afford that right now, please do post the episodes on social media if you are able to do that. That's helpful. And if you can do a review on iTunes or on any other of the podcast platforms, that's also much appreciated. And if you're watching on YouTube, make sure to click the like and subscribe button. All right, let's get into the program. And joining me now is Daniel Whiteson. Hey, Daniel, welcome to Theory of Change.
Thanks so much for having me on. So excited to talk to you about aliens.
Yeah, well, and we have a perfect news hook recently. Of course, Barack Obama, the former president, recently got in the news for people thought he was saying that aliens were real, and he was saying, "Well, I only meant statistically real." And then Donald Trump, feeling like he wanted attention, said he was going to declassify all the stuff that the government has on that, which I somehow doubt that's going to happen. What did you think about all that?
I am curious what Obama thinks about aliens because he's a smart guy and he probably has seen stuff that I haven't seen. So there could have been information there, but I don't feel like we really learned very much. His opinion is sort of the opinion any well-educated, non-technical person is likely to have, that there's lots of planets out there. And so it seems improbable that none of them have life on them. But the problem with that is that science doesn't know whether the chances of life starting on a random planet. So it could very well be that there are 30 cajillion planets out there, but the chances of life are, less than 1/30 cajillion. And so we are alone in the universe. Just the sheer number of planets doesn't tell you that there are definitely aliens out there. Of course, I want there to be aliens, but you have to be very careful in science not to convince yourself of something you want to believe. You need the evidence, and we just have no evidence to suggest that life starts many times in the cosmos.
Yeah, we don't. Well, because we have only seen life on evolve on one planet.
Exactly.
Yeah, and that takes us to from the scientific idea of this. There's an attempt to extrapolate. Well, what are the odds of alien life existing? And that's called the Drake equation. So, what is that for people who don't know?
Yeah, it's a big question. What are the odds that there's life out there that could communicate with us? And so a few decades ago, Frank Drake broke it down and said, well, you can express it in terms of the various pieces. In order for there to be aliens out there who could talk to us, there have to be stars, and those stars have to have planets. And at the time, for example, we didn't know how common it was for stars to have planets. We had only ever seen planets in our solar system until 1995. And so even just extrapolating other solar systems with stars and planets, that was a big leap at the time. It was an unknown. And so then you have to know what fraction of those planets have life, what fraction of those life-filled planets have intelligent life, what fraction of those are civilized, what fraction of those develop technology, and then how long they stick around to potentially communicate with us. And the structure of the equation is very simple. It's just all these fractions multiplied by each other. And, it's the Drake equation. He's famous for it. And you might look at it and say, boy, that's a very simple equation. I mean, look at it compared to like the Schrodinger equation, a partial differential equation. It's all complicated. It's got wave functions in it. The Drake equation seems trivial, but the structure of the Drake equation is really important. It tells you something really deep about the nature of this question. Are there aliens out there who can talk to us? It tells us, because all the numbers are multiplied by each other, that if any of those numbers are zero, it doesn't matter what the other ones are. So if there are no life-filled planets out there, it doesn't matter how likely it is for life to become intelligent because there is no life. Or if the probability for intelligent life to become technological in our way is zero or very close to zero, then the whole number is very, very small. And so, in order for it to work, in order for there to be aliens out there communicating with us, you need everything to line up. You need stars, you need planets around those stars, you need life on those planets, you need technology, you need everything in sync, or it's just not going to happen. That's what the Drake equation tells us.
Yeah. Well, and there are a lot of people who argue that it underestimates the odds by quite a bit,
Yeah.
and
And lots
including the famous Fermi paradox, right?
Yeah, the Fermi paradox says, boy, why haven't we been contacted? Because if you look at some of these numbers, right, this is basically Obama's argument too. Now we know the number of stars in the galaxy is huge, hundreds of billions, and the fraction of those stars that have planets around them is shockingly large. It's something like 10 to 40%. And that number could have been 0.00000001, right? The fraction of those planets with a rocky planet in a habitable zone, boy, that could have been a small number, but it's wonderfully large, which means there's a huge number of potentially habitable planets out there. And that's as far as we know, right? And Fermi paradox, or the Obama paradox, I guess, is saying, look, there's all these planets out there, and the galaxy is quite old. It's been around almost since the beginning. Our solar system's only 4.5 billion years old, but the Milky Way itself is 13-ish billion years old. And in all that time, why has nobody visited us or left a marker for us or something, right? Where is everybody? So that's the Fermi paradox, is to say, if there are all these planets out there, where is everybody? And of course, there's several various answers to that question.
Yeah. Well, and then in your book is kind of the step after all that. So,
Mhm.
assuming these things exist or beings exist, how could we even talk to them, and how could we even understand what they're saying? That's kind of the crux of your book. So, tell me about the background of how you got into why you decided to write it.
Yeah. So I'm very excited for aliens to come. And I was thinking a few years ago, like, why am I excited for aliens to come? Is it just science fiction first contact coolness? And yes, that would be a lot of fun. And I watch a lot of science fiction. But one of the reasons that I'm excited for aliens to come is the possibility that they could fast forward our physics. We've been doing physics for a few hundred years or thousands, if you give the Greeks credit. But if aliens get here, that suggests that they're probably more advanced than we are because we can't get to them, which means they might have been doing physics for millions, billions of years. Imagine what they understand about the universe. Our science could be like preschool level understanding compared to what they've done. Maybe they know what's inside a black hole. Maybe they know how the universe was started. Maybe they know if we're in a multiverse. Maybe they figured all that out. It would be incredible. And it's so frustrating to imagine that those answers are out there, that somebody, some critter out there gets the universe so much more deeply than we do. And they just know these things. And if they just came here and told us, boom, we could share that knowledge. That's the thing that excites me about aliens and their potential arrival. And I noticed that in the physics community, there's a sense that if that happened, that it would be fairly straightforward to download that knowledge. That, we would figure out 0, 1, pi, and then 10 minutes later, we'd be at the chalkboard talking about Lagrangians of the standard model or whatever. And I felt like that's probably naive. And frankly, there's a history of physicists not knowing a lot of philosophy, but having strong opinions about it. And so I decided to read some more about it. Like, well, what do philosophers think? What do linguists think? What do anthropologists think about the chances of really making mental contact with the aliens? Is it likely that they think about the universe the same way that we do, that they've come up with the same descriptions? And, really at the core of it was the question of, is our description of the universe part of a universal, inevitable, singular, unique description that everybody around the galaxy would have to come to? Or does it reflect a human perspective? Has our human senses and questions and moods and cultures somehow affected our description of the universe? Has it colored it? This human lens through which we look through. And I actually pitched this idea of a book without the aliens concept to my teenager. Said, hey, what do you think about a book about whether human physics is universal or not? And he was like, yawn, that sounds really boring. And that was heartbreaking, frankly. But you don't ask for notes and then ignore them. So I came back a week later and I was like, ooh, what if aliens have arrived and they have secrets of the universe, and the book is about whether or not we can understand those secrets? And he was like, oh, I would read that book. And I thought to myself, it's basically the same book, but if you center the aliens, it makes it more immediate. And so it's a philosophical question, is our understanding of the universe universal, or is it local and human? But it matters if the aliens arrive, because it means we can either download, advanced knowledge, or we can't. And that's a big difference.
Yeah, it is. And these are, yeah, and you made a really important point there that I think there's a lot of assumptions that people who work in technology or science, that they think that, oh, well, for these philosophical questions, they're just irrelevant.
Yeah.
No one cares about them. These are just dead guys in white dresses who were talking about stuff that no one cares about anymore. And what this book really, it fundamentally is that these questions of perception, of labeling,
Mhm.
of writing down, these are far more fundamental to what we do, and than we have any idea.
Exactly. And it certainly could be that aliens are doing physics the way that we have, that they were at one point where we are now and then spend the next billion years building on it, and that they show up and they could just fast forward us to that future. That's certainly a possibility. I'm certainly not saying that's impossible. And, I want that to happen. That would be amazing. But I also discovered in doing the research for this book that there are lots of reasonable arguments that suggest that that might be impossible. That aliens, that number one, we might never be able to communicate with them, or they might not even do science in a way that we imagine, or they could ask totally different questions, or their answers could make sense to them, but just not sit with us. And so the book essentially is the strongest arguments I could make against the idea that aliens will do physics the way that we do, because I wanted to explore that. And as I wrote the book, I discovered, maybe I'm actually more excited about the possibility that aliens show up and they don't do physics the way that we do, that there's some fundamental disconnect or mismatch. Because in that scenario, yes, we don't get to instantly advance our knowledge by a billion years, but we learn something deep and philosophically revealing about ourselves, something we thought was the only way to do it. Maybe aliens don't do math, and that blows our minds. And then we discover, oh, wow, there are other ways to express scientific theories that are not in the language of math. And that opens the door to new ways of thinking and understanding the universe. one of the joys of having your mind blown is having new opportunities and new experiences. Just like, if you travel to a distant country and your normal breakfast options are not available and you end up eating like spicy fish soup for breakfast and you're like, wow, how is that a breakfast option? And then you discover, I love it. Oh my God. And you come back home and that's all you eat for the rest of your life. You never would have thought of it. And now it's important to you. And so it would be really exciting if aliens come and they show us something about ourselves we didn't realize was human, that we thought was universal. And it'll tell us something about what it is to be human in the universe, which is maybe even more valuable than understanding quantum gravity.
Yeah. Well, and the you have several fun examples also about humans understanding the humanity of other humans, yeah, speaking languages that are dead languages. So talk about a couple of those if you could on some of the difficulty that people had with them, is like hieroglyphics.
Yeah. So connecting to the earlier comment about the Drake equation, I extended the Drake equation a little bit and added more terms. And we said, well, to have this mental mind meld, we'd have to run into aliens that do science and that communicate with us and answer the similar questions in a way that we understand them. And one of the really fun things is this question that you mentioned of communication. Like, could we actually understand aliens? And if you read a lot of science fiction like I do, usually they get the message, it seems weird, dot, 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 they've decoded it, and it says something intelligible. That step, I'm always like, is it really going to be that easy? And I talked to linguists, and, some of them said, look, it's going to be impossible. If you get a message from aliens, it's going to be encoded in some way that are familiar with, and you're going to have no idea how to decode it. And your usual techniques of decoding, trying a bunch of stuff and seeing what works, won't work because those rely on recognizing the decoded message. Like, in World War II, when the Nazis were encoding their messages and the Brits were building computers, the Enigma machine to look for the solutions, they could tell when they got it right because, boom, there it was in plain text. They could read the German. But if we get an alien message and we try a bunch of decodings, how do we know what we get right? Because we don't know if we can recognize an alien message. So that seems really, really hard. But we don't have any alien messages to play with yet. So in the book, we explore a much easier problem, which is like, let's try to decode languages from the past. Other humans with very similar brains. So this should be easy, right? Let's look at what they wrote and said, can we decode it? And there are famous examples that some people take as inspirational, like, well, we figured out hieroglyphics, right? Okay, but think about how we figured out hieroglyphics. Number one, it took forever. People struggled with this for hundreds of years. Like, the last hieroglyphics were written like maybe 1800 years ago. The last native reader or writer of hieroglyphics died around then, and people have been wondering what these things meant since basically then, and not making a whole lot of progress. And it wasn't until the Rosetta Stone that we cracked it. Right now, we're not very likely to get a Rosetta Stone from the aliens unless they've been listening to our television and came up with like a translation guide for us.
Yeah, they
Right.
speak our language.
Yeah, if they speak our language, right? So, and even with a Rosetta Stone, it took us 20 years to crack it. Like, we had a translated example and it still took us 20 years. And the reason for that reveals something really worrying for people who are excited about translating alien languages. It's because we made the wrong assumption about hieroglyphics. People looked at hieroglyphics and they said, oh, look, it's pictorial. So if there's a bird in it, it's probably about birds, right? And if there's water in it, it's probably about water. That would make a lot of sense. And people actually use this as an argument that like the Egyptians had a purer language, that they'd somehow skipped this step of like encoding it in an arbitrary symbol that wasn't directly and inherently connected, the way like the word for water on a page doesn't look like water. It doesn't have anything to do with water. It's in some sense arbitrary. You could have like any set of scribbles could have meant water. But if it's pictorial, then there's an image there. It's more deeply connected to water, was the argument. Well, it turns out that argument is totally wrong. And that hieroglyphics are not pictorial, they're phonetic. And each one represents a sound that you make as you speak. And so the one for bird, it represents some sound. I don't know hieroglyphics. I don't know what it is, but it doesn't represent birds. And they only figured this out after like 20 years studying the patterns of the sounds in the Greek and in the hieroglyphics. And then they cracked it. So that shows you how it's very easy to make what seem like reasonable assumptions that just don't carry forward and that blind you to the answers. And that's why, for example, that's why it took us so long to crack hieroglyphics. And that's why in other cases, like in Etruscan and in Rungo Rungo and in many other dead languages where there's nobody around who speaks them or reads them anymore, we just don't know how to decode them. And we've been struggling for centuries and we may never figure it out. Which means, like, look, if it's hard to decode a human language, people with identical biological brains in the same environment, probably similar culture. I mean, when compared to aliens, like Etruscans, they lived with the Romans. These are not,
Yeah.
distant from us culturally, and yet we can't figure it out. We have thousands of examples of their writing. We don't know how to decode it. That does not bode well for we get a message from aliens and we figure out how to decode it. Like if we can't do it on easy mode, the chances of us doing it on hard mode, I'm not optimistic.
Yeah. Well, and there's also the opposite problem as well, because, when quasars were first discovered, people thought that they were alien transmissions. And so that took people a while to realize, oh, no, these are just natural phenomena.
Yeah, those were actually pulsars. These
Oh,
are
sorry. Yeah. Yeah.
rotating neutron stars where they emit really intense beams, but the beam emission is a little bit offset from the rotation, and so they're basically
Mhm.
like spinning around, and there's like flashlights that scan across the sky, and so they're very regular, and so they emit constantly. But if you're just in one location, the beam passes over you in a regular way, and when this was discovered, it seemed odd to see something so regular from the sky, and people called it little green men initially. LGM was the note in the original lab book because people thought maybe this is aliens. But now we know, of course, yes, the universe can make very regular messages. And so, yeah, it's hard to pull out messages from aliens from the background. There's another example, the wow signal, which is a huge message at a frequency you might expect to hear from aliens, right? A fairly quiet frequency, and never explained. Now there's like some hypothesis about, basically a hydrogen burp and one thing that was enhanced somewhere else. But at the time, it was like a huge, peak in exactly the frequency you would expect it. But we don't know how to extract any information from it. To know that it was from aliens and not just like some hydrogen burp, we'd have to like discover that it is a message, but we look at it and there's no information content we can extract, which means either we don't know how to decode this obvious message from aliens, or it was just a hydrogen burp with no information in it, and that's very
Yeah.
frustrating.
Yeah. Well, I guess I was thinking the first observation of a quasar, the with the Soviets, where they heard it the
Mm,
first time, and they were like, "Well, what is this? This is incredible." Yeah, it's the same concept, and
yeah.
so like it's you have the problem of both false positives and false negatives,
Hmm.
and with just such we would obviously be a very small number of samples. What can you do with that? And it turns out it might be very difficult. It's certainly more difficult than the 6 months you would see in a typical movie
Yeah, and
about
think
this.
think about the other situation, aliens receiving our messages. Carl Sagan and Frank Drake actually put out a message on some of our probes, right? The Pioneer plaque and the Voyager record. This is their attempt to communicate with unknown aliens with unknown culture and unknown senses. And they did a fine job. They avoided English, they avoided math even. They went for like pictorial representations. But who knows what that means to aliens? If they will even understand it as a message, not to mention like be able to decode it. There's
Or
a
do they
lot.
even have vision?
Yes, exactly. And as wonderful a job as they did, and I think NASA only gave them like 2 weeks, so we shouldn't criticize them too harshly. Um, there's a lot of cultural assumptions in that message. If you dig into it, you really need to know what they're trying to say in order to understand it. I actually took their message and I showed it to a bunch of physics grad students here, which should be an easy audience for this because they're like human physicists with the same brain, and they had no idea what the message was about. They were like, Nobody figured it out in a couple of hours. So I don't know. It doesn't bode well. I think the problem is probably a lot harder than people think it is.
Then there is the question of math and science, which often are perceived to be universal
Hmm.
ideas, and that's a heavily loaded philosophical question as you get into. So let's maybe unpack that of the generic, and then we'll get into why math and numbers even are not universal necessarily.
Yeah, well, we can start with science. It feels like obvious that aliens will do science because in the scenario we're imagining, they show up with their gleaming ships. They have warp technology or wormholes, or even just, they figured out generational interstellar travel or something. They're more advanced than we are. How could they possibly do that without being scientific, right? But I think this is projection of human culture into aliens. You know, Historically we're not very good at imagining how aliens could be different from us. I think Star Trek is pretty typical. We tend to like take humanity, put a croissant on their forehead and say like, okay, that's what an alien is. And we imagine aliens as like, some tweak on humans, but really they could have a very, very different history and a very different relationship with knowledge. And it's not actually that hard to imagine aliens without science because humans didn't have science for a long time, even when we already had technology. Like, how did we develop, bread baking or beer brewing or metallurgy? All these things we developed through trial and error, not by understanding like, the chemistry inside and the yeast and the microbes or the, solid state physics of layers of steel and impurities and all the things that go into um, making swords steel really hard. Like the Japanese swordsmiths, they didn't know all that stuff, but they knew how to make a sword. They discovered it. They had the recipe. And so we were technological for many, many years before we were scientific. And doing science means wanting to understand, wanting an explanation. And clearly, that's been a huge multiplier for technology. Like it's sped up our advancement of technology dramatically, but it means that it's not required, right? You can imagine aliens that just sort of like trial and error their way through technology forever, maybe because they don't care about how things work. They're not curious about it. And if that
Or
seems
they
weird,
figured it out a long time ago
yeah. And
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 forgot
and
about
yeah,
it.
right. Oh, that could be too. And if you think like, well, that doesn't make any sense, think about like, do you care to understand all the technology that you use? I mean, when I'm in the kitchen and I'm baking a souffle, like, I don't need to know the chemistry. Just tell me the recipe, right? I just want to know the how, not the why. And and this desire to understand the universe, it could be human. It certainly is emotional. I mean, I feel a personal need to figure out like what is the fundamental fabric of the universe? How does it all work? I'm desperate to know. But that's an emotional reaction to being alive as a human. It's not necessarily true that aliens feel that way. I mean, my dog certainly doesn't care. His food shows up every single day. I don't think he spends a lot of time wondering about how that happens. He's just excited to eat it. And so it could be that aliens show up and they have warp drives and they don't do science. And when we ask them, like, well, how does that work? Why? And they're like, well, here's how you build it. And we say, yeah, but what's the quantum gravity underneath that? And they say, like, what are you talking about? We just told you how to build the thing. What else do you want? It could be that this curiosity, it could be we're the only ones who feel that way about the universe. And it's part of being human and not part of being alive and intelligent in the universe. And I'm not saying that's likely, but it's certainly possible. And it suggests that we may be extrapolating too broadly the human experience to suggest that like all intelligent aliens will do science.
Yeah. Well, and the other thing about this is that there's the how they conceive of it, and how
Hmm.
so if they did do science, how they would conceive of it. Why would it be similar to the way that we conceive of things at all?
Yeah.
So like the idea. I mean, when you look at multiple ways of expressing different particle physics realities, there's several different ways you can
Yeah.
do it. And so, what that means, of course, is that these expressions, these are just models. They're not
Hmm.
actually reality. The
Hmm.
actual reality that exists is independent of what we can say about it because there's probably, possibly, maybe an infinite number of ways to describe various scientific facts that people think, oh, these are the basic truths, these are the fundamental laws of nature. And it's like, well, that's how it looks like to us in this
Hmm.
part of the universe at this moment in time, at
Hmm.
our scale in size, and moment in space time.
Yeah.
So like those are all kinds of assumptions that people, I think, even a lot of science focused people are making these assumptions. So it's not just like a layperson problem, I think.
Absolutely, I think you're right, and, many physicists, I think, confuse the map for the territory. Our description of the universe doesn't have to be how it actually works, it doesn't have to be that there is a Higgs boson when we're not looking at it and thinking about it, that it's just part of our description, and I'm sure that particle physicists hearing me say that would be like, "What are you talking about? Of course there's a Higgs boson. We discovered it. They won the Nobel Prize for it. I can show you the evidence for it. Like, what are you on, Daniel?" And it's not that I'm disputing the discovery of the Higgs boson. I'm suggesting that that's a part of a way to describe the universe, as you say, but it may not be inevitable and singular and unique. And if you read papers in philosophy, they argue that there could be multiple ways to describe the universe. So, as a concrete example, say the aliens show up and they've done science and we can communicate with them and they have their own theory of the universe and it works just as well. And it doesn't have a Higgs boson in it because it doesn't have quantum fields or anything like that. It's fundamentally at odds with our description, but it works just as well, right? That possibility is real. We can't rule it out. Just because our theory works and has been tested to 10 decimal places doesn't make it unique, right? And of course, there's the chance that they come up with another theory and there's like a mapping from ours to theirs. Like we call things different names, and after 100 years, we can understand, like, okay, your quantum schmiels are the same as our quantum fields. You just call it differently. It's possible you can make a sort of categorical connection, but it's also possible that you can't. We just don't know. And to suggest that, like, look, our theory works very, very well, therefore it's true, I think is making a leap that's not supported by the evidence. It's a leap that we want to believe. And so it's very easy to convince ourselves. All those folks at CERN who helped discover the Higgs boson want to imagine that there are aliens also discovering Higgs bosons and winning alien Nobel Prizes for it. But we don't know that. And we should be extra skeptical of things we want to believe. And it's a philosophical question, not a scientific one, whether our theory is unique. And there's lots of other angles on that. Our theory, we know it's not exact. For example, all the theories we build in science, these are effective approximate theories. There's no chance that our description of the universe is the mechanism of the universe itself, because it's not even designed to be. It's designed to get answers to questions that are limited in scope and describe simplified situations. They're approximate descriptions of what reality might be, and in those approximations, there's a lot of potential fuzziness that can creep in.
Yeah. Well, and these questions, I think the fact that there is imprecision and everything is perspectival, or at least access is perspectival.
Hmm.
Um, I think there it does make a temptation for people to say, "Oh, well, so therefore science is all made up. Therefore, it's just fake." And if
Yeah.
I think the Earth is flat, then it is flat.
Hmm.
And
Hmm.
or just any variety of things, whether it's vaccines. That is an increasingly common attitude that some people are having to say that. So, I mean, what would you say to someone who says, "Yeah, of course, I don't mistake the map for the territory on anything." And
Hmm.
so, therefore, I think that if I eat enough cinnamon, I can live forever, or
Wow.
whatever.
I love your cinnamon theory. That's going to be, you said that as a ridiculous idea, but it's going to be real in a couple of years, I bet. No, it's a really important distinction you're making. Thank you for raising that, because I'm not saying science is fake, or that, our experiments are bunk, or that everybody's been lying to you, or that science doesn't work, right? Science works, and we test it, and science is not a scam, but it's not necessarily unique. So just because it's powerful and just because it works doesn't mean that it's revealing reality as it is. It's describing something that is effective, but we don't know if it's the only way for it to happen. That's very different from saying it doesn't work, and physicists have been lying to you, and they've been resisting the truth, and there's wormhole technology being hidden by the government, or Eric Weinstein's geometric unity is the truth, and physicists refuse to accept it because they've been like hogging grant funding for decades, or some other conspiratorial nonsense. That's a very, very different idea. And we can dig into that if you like. I have strong feelings about it. I think that science is being done in good faith by people who want to understand the universe and want to share that understanding and want to discover reality and spread that knowledge openly and broadly. There are, of course, some people who are bad actors everywhere, but they don't exemplify the process of science. But I do think that physicists are not widely educated in philosophy and tend to have a narrow view on the philosophical implications of their work. So, without knowing philosophy, most of them are scientific realists. They think the theory we're developing is reality, boom, done. Because they don't know about these other ideas. And if you sat down and had a drink or a smoke with them and talked to them about it, they would go, "Oh yeah, wow, I didn't realize I was making a bunch of assumptions that the experiments suggest this model, therefore the model is reality. That last step is an assumption. We don't know, and there are other reasonable ideas that intelligent people have put out." I think they would come around and be like, "Oh, cool." But they just don't know what they don't know, because most of them don't take philosophy. So, and I think also physicists have a terrible track record of assuming that they know things that they don't know, stepping boldly into fields where they're uneducated and making strong statements. So I was terrified of making that mistake with this book, which is why I spent so much time talking to my brilliant colleagues here at UC Irvine in the philosophy and logic of science department, who helped me understand a lot of these questions.
Yeah. Well, yeah, I'm glad you mentioned Weinstein, because actually in the earlier episode that we did on quantum physics, he was somebody who we discussed as well.
Mm,
And it's, and I want to talk about it in the context that people who are inclined to believe these conspiracy theories, or that science is all just one big attempt to suppress ideas and whatnot. And it's like, okay, if there were a mathematical formula that translated to the ability to travel through time and go past, the speed of light, the amount of money you could make off of that is it is more than all the money in the entire world. So
yeah.
whatever grants you might get or be afraid of not getting would be absolutely dwarfed by the amount of money
Hmm.
that you could have
Hmm.
if this stuff was real. And
Hmm.
and people don't even think about that.
Yeah.
I think, and it's really absurd, and it's upsetting to me, frankly.
Yeah, and you make the important point there, which is people don't really think about it. And that echoes the point I was trying to make earlier, which is you should be really skeptical of things you want to believe. A lot of these, stories, science is lying to you, or science is being done in bad faith, or whatever. These are things people believe, these conspiracy stories, because it touches something in them that they want touched. It's some grievance or some anger or some feeling of, oh, the experts are actually dumb or something. It touches something in them they want to hear. Like, I'm part of a special group that understands reality now, or something. And so they don't really apply scrutiny to it. And that's why a lot of these conspiracy theories, they seem like nonsense. And as soon as you look at them, you apply any sort of scrutiny, they fall apart. Like, it, as you say, it doesn't make any sense why the establishment of physics would ignore a brilliant idea from an insider. We're talking about a guy who was like at Harvard in math, right? Not just like some crank on the internet. Why the mainstream physics would ignore this idea, it makes absolutely no sense. But a lot of people believe it, and I suspect that they believe it because it does something for them. It validates a feeling they've had, that experts are jerks or something. It's the same thing we see culturally right now, rejecting science and institutions and elites and all this stuff. And people believe that, even if it doesn't make any sense, and even if it's self contradictory, they believe it because they are hearing something they want to hear. And so that's why you have to be extra careful When you hear something you want to hear, that you're applying your skepticism to it. And that's the thing that animated my project here. Is I wanted to believe that aliens would do physics the way that we do, but how do I know? How do I really know? And especially because I want to believe it, I should be extra careful in promoting that idea, because I could just be believing it without applying enough scrutiny. You got to be very, very careful. And so, to any listeners out there, scientists are not lying to you. Most of them are doing science in good faith, trying to understand the universe. And we're not a coordinated bunch of folks. If there was some idea out there which would overturn reality, like, somebody would be shouting it from the rooftops because it would make their career. We're incapable of pulling off a grand conspiracy theory.
Yeah. Well, and that's the real motive. Like, the only way that you can become a world famous scientist is to say these other guys were wrong.
Yeah.
And I have the proof that here's this other
Mhm,
way, and
mhm.
this is how, this is a more accurate model. Like that's the actual way things work. And
Yeah.
and so I think it comes out of this. There is this, if people have kind of a native or sort of unspoken understanding that naive realism is not adequate, therefore anything goes, and
Mhm.
that is not what you're
Yeah, that's not what I'm saying. I'm not saying let's throw out science.
saying.
I'm saying that there's other ways to understand what we've done. What we've done is real and it works. And the reason you're listening to us right now is because it works, but it doesn't necessarily have the philosophical implications that you might naively assume that it does, you know? And I remember feeling that way. Like, it makes sense. I get it. I remember being an undergrad in physics in my quantum class and seeing the calculation of, the dipole moment to 12 decimal places, and then seeing the experimental result to this and the same number to 12 decimal places, and thinking to myself, like, oh my gosh, this isn't just a description. This is the machinery of reality being revealed. I thought that, and I got chills. It was almost a spiritual moment for me. But now I understand it more deeply. I understand how it's possible to be very, very precise, very, very accurate, and yet still be a map and not the territory.
Yeah. Well, and one way of thinking it, I sometimes will say to people is that things that exist, they exist only because they're aligned with the obligations of the locality that they're in. So,
Hmm.
in other words, and so when people say, "Oh, look at all this incredible order! Look at all these amazing things that exist," and it's like, well, they're compliant with the obligations that of
Hmm.
that locality. So if you are, if you have you can't have a protein that exists above a certain temperature because they melt. And so therefore you can't say, well, gosh, isn't this incredible that there are all these proteins? And it's like, no, that you've just described things exist.
Hmm.
And that's not an argument for any kind of special creation or anything like that. It's or not. It's just simply you're noticing that things exist. That's really what this is.
And how do we even know that they exist, right? We describe
Yeah,
them, we experience them. What does that mean about existence actually? That there's an objective reality out there that
yeah,
resembles our model of it in some way, like, maybe, right? Possibly. But and if we're going to be philosophically skeptical, like, we
that's
don't
right.
really
Yeah, we
know.
perceive they exist.
Yeah. Yeah, exactly. Exactly.
Yeah. Well, okay. So just on Weinstein though, a bit more though, like specifically, what is it that he says, and then why do you think that it's not serious?
So Weinstein has a theory called geometric unity, which tries to explain the standard model and dark matter and dark energy and solve a bunch of puzzles that are outstanding in physics right now. Some of those puzzles include, like, well, we can describe the motion of really, really big stuff using gravity and Einstein's theory. And we can describe the motion of really, really small stuff, particles, using the standard model and quantum mechanics. But we don't know how to bring them together because they tell fundamentally different stories about the nature of reality. For example, quantum mechanics says time is infinite, has to go infinitely far in the back and to the future. And general relativity says, not necessarily. You could actually have a beginning to time. Time is a very different kind of thing. So they tell very different stories about basic components of our universe, and we don't know how to bring them together. And Eric Weinstein says he has an explanation for all of this. And, I'm not a particle theorist, so I'm not an expert in this. I've not read his theory myself, but folks who are experts have read it, and, they find fundamental flaws in it. It's not consistent with itself. It creates these anomalies, as people say, that they create these nonsense predictions. We can include some links in the show notes to folks who have gone through in detail and found technical issues with it. And the problem is not that it has problems. Many theories have problems, but what usually happens is that you write your theory, you submit it for peer review, you publish it, and then people critique it and say, "Oh, well, that's interesting. It has this problem. Maybe it's fixable. Let's work on it," or whatever. Or this has this issue. It's fatal. And usually you respond to that criticism by doing some work and responding to it. But Eric's response is to claim that this criticism is in bad faith and that it's gatekeeping, and they're trying to shut him up. And this is the standard science populist playbook: is do some shoddy work, frankly, and then when the community of experts comments on it, claim that you're being suppressed, or there's gatekeeping, and that you're a victim. And you see the same thing with Avi Loeb, right? He does all this sloppy work and claims that comets are spaceships, and when the experts chime in and say, "Well, here you misunderstood something fundamental about this field because you're not an expert in it and you didn't ask us, you didn't even read the textbook," then he paints that good faith critique as an attack, and now he's a victim, and basically he's Galileo. And so it's the same playbook over and over again, right? Do some sloppy work, it's critiqued by experts, claim to be a victim. And these guys are getting the attention. A lot of people who are outside of academia would love to have experts read their work and comment on it. Their complaint mostly is, nobody's reading my stuff. I get a lot of emails from people who have ideas and want some attention for it. So Eric and Avi and these folks, they have gotten plenty of attention, and people just think their ideas are not great. And it's hard to accept when your life's work is seen as essentially failing in the marketplace of ideas. It's much easier to say, "Oh, it hasn't been taken seriously," or "there's some scheme," or "there's some reason why I'm not being treated fairly." That's harder to accept, and so I understand why it's a bitter pill to swallow. But I think it's a simpler explanation than there's some conspiracy out there for physicists who don't want to understand the universe and read your genius theory, and are rejecting it for political reasons or something. It just doesn't make any sense to me.
No, well, and not economic sense either, as I said.
Yeah,
If he
absolutely.
was right, the dude would be, an instant multi-billionaire, the richest person ever to have existed, if
Mhm.
what he said was real.
Yeah.
Um, and and again, like he's the managing director of Peter Thiel's Capital Fund. So is Peter Thiel suppressing Eric Weinstein? Yes, apparently.
Well,
um,
Eric Weinstein gets more attention than almost any physicist on the planet for his theories. Like, he has a bigger platform and more attention than almost anybody. So the idea that he's being suppressed is ridiculous. He's got a huge platform, and this is a trend in alt science. You see this also in like archaeology. Guys like Graham Hancock who are suggesting that like archaeology is lying to you about our history, and he's got the real story, but it's being suppressed. Like, the guy has a show on Netflix. He has a bigger platform than almost any archaeologist out there. And so it's one of these things where, again, the story doesn't hold up to even the flimsiest of scrutiny, but it's not supposed to. What it's supposed to do is touch on some part of you that makes you want to believe it. Oh, I also got ignored by experts, so I'm going to believe Eric Weinstein, his theory is being ignored. Or some nerd was mean to me decades ago, and so I'm going to think that professors are jerks or something. I don't know what it is inside folks, but Graham Hancock and Weinstein and Loeb, these guys are experts at touching on those grievances and using it to get people to believe stuff which is inconsistent and incoherent.
yeah. Well, and unfortunately, there's one person in the astrophysicist community who has apparently gone down that road as well. And I think you know who I'm referring to, right?
Yeah, the
You
man
want to
from
discuss
Harvard.
kind of what you think happened with Sabine Hassenfelder?
Oh, I see, Sabina. I don't know Sabina, so I can't say what's in her heart. But I find her descriptions of particle physics confusing because they don't resemble my experience at all. She says things like particle physicists are basically doing physics in bad faith, that we're proposing theories we don't believe in because we're going to get grant money for it, and that we're suppressing good ideas like hers from getting funding. And, I think everybody has had the experience of putting your heart and soul into something and then having the community read it and be like, "Nah, I'm not excited about that." My success rate for writing grant proposals is terrible. I write many, many grant proposals and do not get most of them funded. That's just the way that it works. And so it would be easier for me also to say, hey, my ideas are actually brilliant, y'all, but the community is ignoring them because they want to promote their ideas, which are nonsense. And I think that she probably has a legitimate disagreement with the mainstream of physics, and she probably legitimately thinks they're going in the wrong direction. But almost everybody thinks that because almost everybody has had their juicy ideas rejected. And the answer is not to suggest that the mainstream are somehow doing it in bad faith because they disagree with you. Like, disagreeing with one person like Sabina doesn't mean that they're lying. Um, so I don't know what's in her heart, or what her motivations are exactly, but her description of physics and particle physics specifically is not resemble the reality of my experience at all. But she's built a big audience, and again, I think a lot of the people who hear mainstream physics is a scam, and they're doing it for the wrong reasons, and et cetera, et cetera. They hear that and they want to believe it. And so even if it doesn't quite make sense, or if she has conflicts of interest herself, she has reasons to tell you that story, and for you to want to believe it. They brush that aside, just the way people brush aside contradictions in Donald Trump's story, because they want to believe it. It does something else for them. That's my theory, but again, I don't know her personally, and so I wouldn't want to speak to what's in her heart, or why she's doing what she's doing.
Yeah. Well, and I would also say follow the money for them, because,
Hmm.
even if, let's say, you are well funded, you're the chair of a department at some major university, the amount of money that you're making off of that in a given year is far, far less than what Eric Weinstein makes off of his YouTube and off of his podcast and all these
Very
other things
likely.
that he's doing. Like, this guy's making way, way more money than
Yeah.
any scientist out there.
Yeah.
So you have to realize, if you're going to say follow the money, well, follow it the other way too. That's
Yeah.
that's
That's right, but you're making an assumption there, which is that people are applying some sort of standard to this content and digesting it and thinking about it before accepting it. And I don't think that they are. I don't think that they're applying a fair standard, because, as you say, if they did, they would listen to Sabina's message, follow the money. Physicists have an incentive to promote ideas that they don't believe, and say, well, Sabina also has an incentive to promote, ideas that the audience wants to hear, to pander to her audience. Does that mean we shouldn't believe her? But I don't think people are applying that standard because they're hearing what they want and they're believing it because they want to believe it, and they're applying a much lower bar of scrutiny to it, in my view. But again, I'm not an expert in this stuff. This is psychology and social and sociology.
Yeah. Well, and I'll say that that's the regular domain of this show, so I couldn't resist.
Okay.
But back to your book, though. I mentioned we'd talk about, so we talk about science as a not necessary universal,
Hmm.
but also there's the idea of math and even numbers,
Yeah.
and that's, I think that is another thing that is probably much less widely considered. That
Hmm.
what even are these things from a universal perspective? They don't necessarily. They're not universal, and you do get into this quite a bit in the
Yeah.
book. So talk about it here, if you would,
Sure.
please.
And first, let's acknowledge the arguments for math as a universal language, because they're very strong, right? We can't ignore that. Like, our physics is just math. Like, it's the language of math. It's expressed on math, and more than just being described in terms of math, math has led us to physical insights. Just blindly following the math has revealed the way the universe works in some cases, like Maxwell putting together all the equations of electricity and magnetism and realizing there was a missing bit. Like if you added one more piece, then those equations would be much more symmetrical and how satisfying and mathematically beautiful. But you can't just like come up with stuff and say, hey, it would be prettier if it was this way. But then they went out and looked and like, oh, that actually was there. It was something about the universe we had missed. And math pointed us in that direction. And that's happened many, many times. Some of my favorite examples are, times when mathematicians were just playing with numbers and patterns because, that's what those nerds love to do. And I love that they love it. And built whole like tools like group theory was just based on, hey, what can we do with this? Let's play some games with numbers. And it was totally useless from a physical point of view for more than a century until particle physicists were like, oh my gosh, these rules you built from group theory describe exactly what we see happening to fundamental particles and the symmetries between those particles. This is perfect. And now everything we do is built on group theory. So, just from the mathematical ideas, we discover lots of mathematical structure in our explanations of the universe. Very, very powerful stuff. On the other hand, right, how do we know that it's not, how do we know that it's part of the universe and not just our description of it, right? Can we really pull those two things apart? And so that's the question we dig into in the book. And, one question is like the rules themselves, do they have to be mathematical? And the other is that you refer to is what about the objects in those stories, like the numbers? What are numbers? And if you read books on philosophy of math, the questions they ask are trippy, right? Like, what is a number? Or here's my favorite, where are numbers? Because if numbers are real in the universe, the way like some people think the Higgs boson is real or Earth is real things have locations, right? Earth is somewhere. The Higgs boson is here and then it's there and then it disappears. Where's the number two? it's not anywhere. You can't do experiments on two. You can't trap two by two, bring two with you. It seems like more of an idea than an actual, physical thing in the universe. And there's this wonderful thought experiment, extended thought experiment by Hartree Field, where he says, let me try to build a theory of physics without numbers. So it's called Science Without Numbers. And it's crazy, but it works. And what he does is he says, think about the number line, right? And people mostly imagine in their heads some like, glowing line in space with dashes on it. It says that's kind of an abstraction. That's a construction. We have started from the idea of having like more things and less things, and we've given like names, and we've assembled that into a line, and we've given names to it. But you don't need all that. And that's really fundamental to the way we do physics. Like most of physics today is built on fields. Fields are just numbers in space. Like what is the Higgs field? It's just a different number at every place in space. Or even like gravity, Newtonian gravity has gravitational fields, which are, numbers or vectors in space. So if you don't have numbers, you can't have fields. How do you do calculations? Well, Hartree, I love that his name coincidentally is called Field. Hartree Field says that fields don't exist, and that they're an intermediate step in our calculation. Like when you go to calculate what happens to a rock orbiting Jupiter, yeah, you could use the gravitational field, but you don't actually need it. It's just like a shorthand. It's a way to like store a half done calculation to make the rest of the calculation easier later. You can skip all that. All you really need to know are the comparisons to know like what's closer, what's further, those relationships without building this abstract concept of a number line. And so he builds a theory of gravity that replicates everything that Newton's theory does, but doesn't use any numbers, right? And it's mind-blowing, and it's very hard to grok because it's very different from the way we think, and it's not very useful, right? Because of course you would want to use numbers are very powerful, but he makes the point by doing so that you could build science without numbers themselves. This idea of a number line may be an abstraction that we put together to organize our thoughts and may reflect the way that we think about the universe more than the way the universe itself operates.
Yeah, and for alien beings that might have significantly different physics in terms
Mhm.
of how they're structured, these could have very real implications for them
Yeah.
because if they themselves don't really experience quantity,
Hmm.
in terms of what they are, then why would they think of things outside of the world as quantity? That's
Yeah.
not necessarily true, right?
And to be more concrete, about quantity, we tend to think that math is intuitive and basic and simple because, um, 1 plus 1 equals 2, and surely critters out there will feel the same thing because aliens, will have themselves and they'll have their partner or whatever. But there's some assumptions built into that. Like, what if aliens don't have distinct boundaries between their bodies? What if they're currents in some flow or tendrils of plasma in a star's atmosphere, or as if you say their physicality is fundamentally different in a way that's hard for us to imagine. They might not come up with this idea of counting, and counting is the foundation of all of our mathematics. If you take apart all of modern mathematics, folks showed that the foundational assumptions, the axioms of math, come from arithmetic, come from counting. And so if you're not
Which
counting,
and they're rooted in our physical body, like that. Our
exactly.
hands have digits, like they're
Yeah.
literally called digits.
Yeah, that's true, exactly.
You can't get any more
That's right.
illustrative of the assumption there, I think.
That's right, and the idea that, like, I have a body and you have a body, and those are separate and distinct, and we can count them. There's a lot of assumptions there, like, if you wanna be if it was somehow physical and universal and absolute, then there would be no fuzziness there, but there's lots of fuzziness, like, where exactly does my body end? Is it at my skin? What about the hairs? What about, a dead hair that's now sitting on the surface of my skin? Is that part of me, or is it part of the rest of the universe? It's an
Yeah.
arbitrary cultural distinction we make about where our
Are the
bodies
bacteria
end.
inside of your body, are they
Exactly,
you,
right?
or are they
Exactly,
not?
and what we find is that this is a human choice, which means it's cultural, and even among human cultures, we count things differently. Like, if you throw a bunch of stuff on a table and you say, "How many things are there?" An American might say, "Oh, there's 7 things," and a Japanese person might say, "No, no, you can't group these things with those things. You count those things differently. There's 4 long things and 3 short things. Like, that's it. You can't group those together. Like, you don't count them the same way." and and so there's a lot of assumptions about, like, what gets counted together. What does counting even mean? And the deeper you go down this rabbit hole, the more you realize there's very little that we can assume about how aliens' minds might work if we don't even know that 1 plus 1 equals 2 for aliens.
Yeah, exactly. And that's, and you don't even get into category theory in the book.
Yeah.
Like you could certainly do that as
Mhm.
well, which is, expressing concepts through directionality. And
Yeah.
that could easily work for,
Mhm.
you could build an entire theory of physics that could be just as more complex even
Mhm.
than the human theories based on category theory or some
Yeah.
variant of it.
Yeah. Absolutely.
So okay, but let's fast forward then to the end of the book here. So what are, after all the paradoxes and questions that you explore, what are kind of the takeaways that you have for people in terms of the question here? Do aliens speak physics? The answer is, well, probably not. But what can we do after realizing that?
Yeah. So after realizing that, and being let down, I think we should embrace what that means. It means that probably our physics is not unique, it's not singular, it's not inevitable, that there are other ways to think about the universe and to explain it. And that means that when the aliens arrive, and I'm very hopeful that they do very soon, tomorrow would be my preference, that we're going to learn something about the universe, but also we're going to really learn something about ourselves. We're going to understand our relationship to explanations and our relationship to building those explanations and the choices that we made along the way that we didn't even realize we were making because they felt so natural to us. They're the only way you could possibly do it. Of course, you're going to have bacon and eggs for breakfast. What else could it be? And the having effectively fish soup for breakfast is gonna blow our minds, but it's gonna also open up lots of possibilities because there are lots of doors there that we've closed, and opening them up could reveal fantastic new ways to explore the universe, to explain it, to understand it. And so it might sound disappointing that our project of physics is actually just a human earth-based project like biology or economics. Physics doesn't have a special status in that way. but it's actually an opportunity. It's an opportunity to learn a lot about ourselves and humanity. What that means, I don't know. I'm desperate for the aliens to show up and to blow our minds that way. But of course, this is just speculation. And it could be that when the aliens come, they do speak physics our way. And that tells us something else about the universe. So, in the same way that, like, discovering alien life will tell us a lot about our context here and the meaning of our existence. Are we alone? Are we, one of a zillions of civilizations? Discovering whether aliens speak physics the way that we do will tell us a lot about the context of our understanding and our desire to explain the universe. If everybody out there is doing it the same way we are, then we really are revealing something about the universe itself. And if they're not, then, we're revealing something equally interesting about ourselves.
Yeah, exactly. And also, I one of the other things that I thought was kind of, it made me think, reading the book is, there are also so many ways of perceiving and being on this
Mhm.
planet.
Yeah.
Even outside of the human context, like octopuses with their distributed nervous system,
Mhm.
and not having bones. I mean, there's just so much we can learn from them, and we barely know anything about them, to be
Yeah.
honest. And that's why it's really important to continue to support science funding and make sure that because people say, well, I want to know the answers to these questions. Well, the first thing you do is you don't cut the funding for science.
Oh my gosh. I know. I mean, there's so many reasons to support science funding. If you want to understand the nature of the universe, it turns out the answers are there and they're pretty cheap. Like, just spend a little bit of money, a tiny fraction of what we're spending bombing Iran, and we could just buy answers to questions about how the universe works or life. Like, it's cheap compared to other things we spend money on. Or if you're excited about, like, economic wealth, then the cheapest thing you can do is give nerds money and let them play with it, and they will invent things that make you rich, make us all rich. The reason that we have our quality of life today is because decades ago people gave nerds money to play with and they built cool stuff, and that stuff powers our lives. And it's, yes, it costs money, but it's an incredible return on investment. So if you believe in humanity or America or whatever, then it's a great investment to make. And if you want, cultural or military hegemony, you want to dominate the world with your weapons and your language and your music, then, like, spend money on science, because that's what you get. So frankly, I don't understand why science funding is not a bipartisan issue. It should be across the spectrum. Everybody should recognize that it's good. um, it's a tragedy in my view.
Yeah. Well, it was for a long time. So,
It
in
was.
fairness, we should say that,
Yeah, it's
and
true.
hopefully it will become that way again. So, this has been a great conversation, Daniel. So, for people who want to, besides buying your book, which they should, what
Thank
else?
you.
What other kind of advice do you have for that as far as keeping up with your stuff?
Yeah, well, if you're curious about this kind of stuff and you want to know more about the universe, I have a podcast myself. It's called Daniel and Kelly's Extraordinary Universe, together with my friend Kelly Wienersmith. We talk about the nature of the universe, how it works, what's inside a black hole. And Kelly's a biologist, so we talk about all sorts of things about, like, parasites and polio and perimenopause. And our goal is to share the joy of understanding this universe, because it's an extraordinary universe we live in, filled with mystery and wonder and beauty and violence. And it's a pleasure and a privilege to get to explore it. And the podcast does a deep dive into these topics, but it stays accessible and fun. So go check it out, Daniel and Kelly's Extraordinary Universe.
All right, sounds good. Thanks for joining me today.
Thanks so much for the really fun conversation. Really appreciated it.
All right. So that is the program for today. I appreciate you joining us for the conversation. And you can always get more if you go to theoryofchange.show, where we have the video, audio, and transcript of all the episodes. And if you're a paid subscribing member, I thank you very much for your support. That is much appreciated. This is a tough time for people to be in media that are trying to produce substantive content. So I really appreciate your support. Thanks a lot. I'll see you next time.